In this video, we will find a relationship between EMF, back EMF, and resistance in a series electric circuit. For this purpose, we will study a simple series circuit composed of a generator of EMF uppercase E and internal resistance R1, a passive component of back EMF lowercase e and internal resistance R2, and a resistor of resistance R, in addition to connecting wires which are represented in the figure with black lines. To start, let's apply the law of addition of voltages between the positive terminal P of the generator and its negative terminal N. VPN equals VPA plus VAN. But we know that VPN equals E minus R1 multiplied by I. VPA equals E plus R2 multiplied by I, and VAN equals R multiplied by I. If we replace in the first equation each one of the three voltages by its expression and isolate the EMF and back EMF on one side of the equation, we will be able to notice a common factor, I, on the other side of the equation. We can factor and get a general relationship which can be written as the sum of all electromotive forces minus the sum of all back electromotive forces is equal to the product of the current carried by the circuit and the total resistance of the circuit. Example: a series circuit contains a generator, a motor, a voltmeter, an open switch, and two resistors with the given values. Determine the current when the switch is closed. To answer this question, we apply the already derived formula. We replace sigma EMF by 12 volts and sigma back EMF by 6 plus 4 volts and the resistances by their values. We get 2 equals 20I, thus I equals 2 over 20, which gives I equals 0.1 amp. And this is all for this video. Thank you for watching.